When upgrading a service on an old home wired with old armored cable, you may encounter situations where the armored cable lacks an internal bonding strip. This presents specific challenges regarding grounding and safety. National Electrical Code Section 333.19 prohibits the use of armored cable that lacks an internal bonding strip. National Electrical Code Section 250.299 requires an equipment grounding conductor to be provided for all electrical equipment. To address these concerns, several steps should be followed. Firstly, disconnect the armored cable right where it goes down to the old fuse panel. This is typically done in the attic. Secondly, install a junction box in the attic. This junction box will serve as the connection point between the old armored cable and the new non-metallic cable that runs to the new service panel. Thirdly, ground the junction box. Connect the grounding wire from the non-metallic cable to the junction box. This provides an equipment grounding conductor for the junction box and the new panel. Fourthly, cut the grounding conductor from the armored cable where it enters the junction box. This action breaks the electrical continuity between the armor and the new panel. Fifthly, bond the armored cable. Connect a grounding conductor from the armored cable armor to the junction box. This ensures that the armored cable is properly grounded. The rationale behind these steps is to prevent potential ground fault current from traveling through the armor. By cutting the grounding conductor from the armored cable, the continuous path between the armor and the new panel is broken. This reduces the risk of overheating and fire, which can occur due to the high resistance of unbonded armor. The armor remains connected to the junction box, providing a proper grounding path for the entire circuit. Additional considerations include assessing the old fuse panel's grounding capabilities. It's often unlikely that the old fuse box provided a reliable grounding path for the armored cable. Therefore, it's generally not necessary to maintain this connection to the old fuse box. Addressing the fire risk associated with high resistance paths on unbonded armor is crucial. By breaking the continuity between the armor and the new panel, you are actively mitigating this risk. These methods aim to ensure compliance with National Electrical Code requirements while specifically addressing the potential hazards associated with unbonded armored cable. When working with electrical systems, especially in older homes, it's essential to understand the purpose of each component and the potential risks involved. Grounding is a critical safety measure designed to protect people and equipment from electrical shock and fire hazards. The equipment grounding conductor provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and to energize the circuit. This process minimizes the duration of the fault and reduces the risk of electrical shock or fire. In older homes, the grounding system may not be as robust or up-to-date as modern systems. This is often the case with armored cable that lacks an internal bonding strip. Without a dedicated bonding strip, the armor itself becomes the primary grounding path. However, the armor's high resistance and segmented construction can make it a less effective grounding path compared to a dedicated copper conductor. When upgrading an electrical service, it's important to carefully evaluate the existing grounding system and make any necessary improvements to ensure that it meets current code requirements and provides adequate protection. This may involve installing new grounding electrodes, upgrading the size of the grounding conductors, or replacing outdated equipment. One of the key considerations when working with armored cable is to ensure that it is properly bonded to the junction box. This can be achieved by using a grounding bushing or connector that is specifically designed for use with armored cable. The grounding bushing or connector should be securely attached to the armor and connected to the equipment grounding conductor. Another important consideration is to avoid creating ground loops. A ground loop occurs when there are multiple grounding paths between two pieces of equipment. This can create a circulating current that can interfere with the operation of sensitive electronic equipment and increase the risk of electrical shock. To avoid ground loops, it's important to ensure that there is only one grounding path between each piece of equipment. When splicing or terminating armored cable, it's important to use the correct tools and techniques. The armor should be cut cleanly and smoothly to avoid creating sharp edges that could damage the insulation and the conductors. The conductor should be properly stripped and terminated to ensure a secure and reliable connection. It's also important to follow the manufacturer's instructions when installing any electrical equipment or components. The manufacturer's instructions will provide specific guidance on how to install the equipment safely and correctly. In addition to following the National Electrical Code, it's also important to comply with any local electrical codes or regulations. Local codes may have additional requirements or restrictions that must be followed. When in doubt, it's always best to consult with a qualified electrician to ensure that the electrical work is done safely and correctly. A qualified electrician will have the knowledge and experience to properly evaluate the existing electrical system and make any necessary improvements or repairs. They can also provide guidance on how to comply with all applicable codes and regulations. Remember that working with electricity can be dangerous. It's important to take all necessary precautions to protect yourself from electrical shock and other hazards. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. And never work on electrical equipment if you are wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the electrical work is done safely and correctly. The steps outlined in the solution address the specific challenges presented by upgrading electrical service in an older home wired with old armored cable. By disconnecting the armored cable, installing a junction box, grounding the junction box, cutting the grounding conductor from the armored cable, and bonding the armored cable, you can create a safe and code-compliant electrical system. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Understanding the National Electrical Code and its requirements is crucial for ensuring electrical safety. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date on the latest version of the National Electrical Code and to understand how it applies to your specific situation. The National Electrical Code provides detailed guidance on a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. When working with electrical systems, it's important to follow all applicable National Electrical Code requirements. This will help to ensure that the electrical installation is safe and reliable. The National Electrical Code is not a law, but it is often adopted by state and local governments as part of their building codes. This means that compliance with the National Electrical Code is legally required in many jurisdictions. In addition to the National Electrical Code, there are also other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as Underwriters Laboratories, the Institute of Electrical and Electronics Engineers, and the National Fire Protection Association. It's important to be familiar with these other standards and guidelines and to follow them when applicable. Electrical safety is a shared responsibility. Everyone who works with electricity has a responsibility to ensure that the work is done safely and correctly. This includes electricians, contractors, homeowners, and anyone else who performs electrical work. By following the National Electrical Code, using safe work practices, and being aware of the potential hazards, you can help to prevent electrical accidents and injuries. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary precautions to protect yourself and others from electrical shock and fire hazards. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to do the work for you. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and correctly. They can also ensure that the electrical installation meets all applicable codes and regulations. Upgrading electrical service in an older home can be a complex and challenging task. It's important to carefully evaluate the existing electrical system and make any necessary improvements to ensure that it is safe and reliable. This may involve replacing old wiring, upgrading the service panel, installing new grounding electrodes, or adding additional circuits. When upgrading electrical service, it's important to consider the future needs of the home. This may involve adding additional circuits to accommodate new appliances or equipment. It's also important to ensure that the service panel has enough capacity to handle the increased load. In addition to upgrading the electrical service, it's also a good idea to install arc fault circuit interrupters on all branch circuits. Arc fault circuit interrupters are designed to detect dangerous arc faults, which can cause fires. They are a valuable safety device that can help to protect your home and family from electrical fires. When upgrading electrical service in an older home, it's important to work with a qualified electrician who has experience with older wiring systems. Older wiring systems may have unique challenges that require specialized knowledge and skills. A qualified electrician will be able to identify any potential problems and recommend the appropriate solutions. Remember that electrical work can be dangerous. It's important to take all necessary precautions to protect yourself from electrical shock and other hazards. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. And never work on electrical equipment if you are wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the electrical work is done safely and correctly. In conclusion, upgrading electrical service with old armored cable requires careful attention to detail and a thorough understanding of the National Electrical Code. By following the steps outlined in the solution and taking the necessary safety precautions, you can create a safe and code-compliant electrical system.